Salamat sa inyong patuloy na pagsubaybay dito sa ating discussions about mechanics of deformable bodies. Ang magiging topic natin ngayon ay isang sample problem about stresses beams. At sa pamamagitan nitong sample problem ay sana ay makatulong sa inyo para lalo ninyong maintindihan itong topic na ating tatalakayin. So, ganito yung problem, guys. Meron tayo ditong wooden beam na 150 mm by 300 mm ang cross section. And loaded siya, okay, as shown in the figure. So in the figure, meron siyang uniformly distributed load na W at concentrated load at the end. The beam is an overhanging beam. Diba? So the cross section of the beam is 150 by 300 at meron siyang capacity na 9 megapascal. Yun yung kanyang maximum flexural stress. So ang requirement sa atin ay kunin natin or hanapin natin yung maximum distributed load W and concentrated load P na pwedeng i-apply dun sa beam simultaneously. So kumbaga, we are looking for this magnitude of W and P so that when they are applied simultaneously, hindi masisira yung ating beam. So, guys, bago natin to solvein ay siguro maganda na magkaroon tayo ng konting hint or considerations mga pointers na pwede nating gamitin in solving for the problem. At ito na rin yung ating magiging guide para solvein yung solution, ipakita yung solution. So, dito kinakailangan na dahil given yung property natin na 150 by 300 mm ay we can compute for the maximum moment capacity of the beam using the flexure formula. So we already have derived the flexure formula kung saan if we have a rectangular beam, so we can simply compute for the maximum moment capacity ng beam using the formula 6m over BD squared, na kung saan yung m doon yung kanyang maximum moment na pwedeng i-resist, no? At yung B yung width ng ating beam and the depth of the beam given in terms of D. So given kasi ito, pwede natin makompute yung kanyang maximum moment capacity. Then dahil nga yung loading natin ay unknowns, so yung reactions natin ay makukumpute natin sa pamamagitan din or in terms of the unknown values. So we can compute for the reaction of these supports in terms of W and in terms of the P values, in terms of these two values, W and P. And then after we have computed for this reaction of the support, so by drawing natin yung load, shear, and moment diagrams out of these given values. Ibig sabihin, yung ating shear diagram will be expressed in terms of W and P. And then yung moment diagram natin should also be expressed in terms of W and P. Ngayon, ano yung magiging objective natin? Kung bakit natin i-drawing itong shear and moment diagram. Ang magiging objective natin dito ay para makuha natin yung maximum bending moment, both the maximum positive and the maximum negative bending moments. And this maximum bending moments can be expressed in terms of the unknown W. Kasi do-drawing natin siya using the unknown W. And pagkatapos nating makompute, halimbawa yung maximum positive bending moment at saka yung maximum negative bending moment, so we will be equating the maximum bending moment to the moment capacity of the beam given the cross section of 150 by 300. So gagawin natin, equate natin yung maximum bending moment capacity of the beam cross section and the maximum moments both the positive and the negative kasi meron tayong dalawang unknown, so kailangan mag-produce tayo ng dalawang equations. At yung dalawang equations na yon ay makukuha natin kapag inequate natin yung moment capacity ng section doon sa maximum positive bending moment. Isang equation yon. And then, pag inequate natin yung maximum moment capacity ng cross-section doon naman sa negative bending moment, another equation din yun. Kaya dahil meron tayong dalawang equation, we can already solve for the unknowns W and P. So, ganun yung magiging paraan para ma-solve natin yung problem. Ano? Kaya ipakita natin yung ating magiging solution. Una, ay mula doon sa beam cross-section na 150 by 300, solve natin yung kanyang maximum moment capacity. So, we are given here the beam cross-section. Meron tayong width na 150 at meron tayong depth of 300. So, kung marirecall natin yung ating stress formula na na-derive natin in the previous lecture na in-upload ko dito sa video na ito, channel na ito, yung ating stress is equal to MC over I, na kung saan yung C is the location of the farthest fiber mula doon sa neutral axis. Yung I naman, yun yung kanyang moments of inertia of the beam cross-section with respect also to the neutral axis. And for a rectangular section ng beam, ito ay pwedeng masimplify into what? Into a formula that is stress equal to 6M over BD. Tandaan natin, itong 6M over BD na ito ay applicable lamang kung ang ating section ay rectangular. Kung hindi, di mananatili tayo dito sa equation na ito. That stress equal to K is equal to MC over I. Ano? Kaya solve na natin itong maximum K moment capacity ng ating beam. So, yung ating given, yung maximum stress capacity ng beam ay given na 9 megapascal. So, pinukulang itong 9 megapascal. Yung ating width ng beam is also given, 150. Yung depth niya is also given, 300. Kaya from here, we can compute. When we substitute the value, we have 9 Newton per square millimeter equal to 6M over BD. Kaya pag sinimplify natin dito, yung M masosolve natin na 20.25.000 Newton millimeter. Ang resulting unit ito will be in Newton millimeter. Kaya kung ito i-convert natin to a much larger unit, this can be converted into kilonewton meter and this becomes 20.25 kilonewton meter. So ito ngayon yung kanyang moment capacity na kung ating babalikan, dapat ito ay ma-equate natin dun sa maximum bending moments due to the loadings. Yun yung maximum positive at maximum negative. So makatwid, ano ang kinakailangan natin gawin? So, kinakailangan nating ma-drawing ngayon yung shear and moment diagrams. At magsisimula tayo sa pamamagitan ng computation ng ating reactions. Ano? Reaction at the support by applying the condition of moment. Okay? So, ano yon? So, if we will apply summation of moment about this point, about an axis through A equal to 0, and we consider counterclockwise as positive, mula dito, masolve natin itong R sub B, yung reaction dito, masosolve natin. Diba? Kaya pag in-apply natin yung equation, R sub B multiplied by 8, ito yon, diba? K minus W multiplied by K, the total span, where W is acting, multiplied by the moment arm acting at a distance at the center of the rectangular loading 4 meter from A. Kaya I have here W times 8 times 4. K minus itong moment due to P, which is P multiplied by 10. Ito yon, must be equal to 0. And then from there, masolve natin ngayon yung R sub B equal to 4W plus 1.25P. So mapapansin natin, yung ating RB dito is expressed in terms of the unknowns K, W, and P. Diba? Ngayon, kapag solve naman natin yung moment summation about A, dito naman tayo nag-moment B, nag-moment summation about B, masosolve naman natin yung reaction at A. So that, if we will apply, okay, we will apply the moment summation about b equal to 0, and we consider also, okay, counterclockwise moment as positive. From here, masolve natin yung R sub A. Masolve natin dito, di ba? So, na yung ating moment equation? Ang ating moment equation will be KW times A times 4. Itong moment due to this W, okay, about an axis through B. That is W multiplied by this span multiplied by the moment arm acting at the center. Okay? Minus P multiplied by 2. Itong moment nito, about point B. And it is producing a clockwise moment. Kaya that is negative. Shall be minus RA. RA is also producing a clockwise moment also about B. So that is also negative. Okay? RA multiplied by 8, and that will be equal to 0. Pag sinimplify natin ito, we shall be able to solve for RA, both expressed in terms of W and P, and the value is, okay, 4W minus 0.25 of P. Kaya itong R sub A natin will be 4W minus 0.25 of P. Diba? So, ako kapag nagsosolve ng problem, nire-recommend ako sa mga estudyante ko na before proceeding further, kasi nga yung ating dalawang unknowns ay kinumpit natin individually, mas maganda na ma-check muna natin yung kanyang ating na-complete na reaction para sigurado tayo na yung ating solution will be correct. So, paano natin sosolve yung, i-check yung ating reaction kung tama? So, we apply the other conditions of equilibrium, that is summation of force vertical. That we will apply the summation of force vertical, that must be equal to 0. So, we have to check for RA and RB. So, how do we check it? So, yung bagang summation of force vertical natin equal to 0. So, if we will add RA and RB, that must be the sum of the total weight due to the uniformly distributed load at yung P. Kaya, tanong natin, RA ba plus RB will be equal to 8W plus P. So, substitute natin yung RA, which is equal to 4W minus 0.25 of P. Pag sinubstitute naman natin itong RB dito, we have here 4W plus 1.25 po, yung by equal sa 8W plus P. So, when we simplify, okay, yung 0.25 dito, mababawasan dito, ito will be added. So, this becomes 8W plus P on the left, equal doon sa 8W plus P on the right. So, makatwid, okay siya, no? Sabihin nun, tama yung ating computation for RA at saka yung RB. So, ang ibig sabihin pati doon, safe tayo to continue. So, hindi tayo mag-worry na sa haba-haba pala ng ating ginawang solution ay mali pala yung ating computation for R sub A and R sub B. So, yun ang suggestion ko kapag nagsusolve tayo ng problem. Before you proceed further, dapat masigurado natin, earlier computation pa lamang natin itama na by checking our work. Diba? So, pagkatapos nating masiguro na tama yung ating reaction, so what shall we do now? So, we can now draw for the shear and moment diagram. Tanggalin ko lang itong bahagi na ito. So, we can now draw the shear and moment diagrams. Diba? So, simulan natin by drawing the shear moment diagrams. Itong drawing natin part nito. So, let us try to draw the shear diagram dito. Here is our shear diagram. This is our point A. Ito yung ating point B at ito yung ating point C. Diba? So, gaya ng discussion ko before, dapat yung ating shear diagram will start at 0. Kaya yung ating shear at A, the left of A must be equal to 0. Kaya ito magsisimula siya sa 0. Diba? Then we go to the next point. Ano ba yung next point? Kasi ito ay concentrated load. The next point must be the right of the concentrated load. And that is the right of A. And it is equal to the shear at the left plus whatever is the concentrated load at point A. Yung concentrated load natin sa point A is given by 4W minus 0.25 of P. Ito yun. Diba? Kaya pag sinimplify natin yung ating value, yung ating value at the right of A will be 4W plus 0.25 of P. Ito rin yung value na ito. No? Kaya pag pakita natin ito, yun yung point natin, and we have the value of 4W minus 0.25 of P. Ito yung naipakita ko na sa ating discussion. Itong vertical distance na ito, nagre-represent siya ng concentrated load at that point. And because it is upward, therefore, it will be connected by an upward force, upward line. Ba? So, pagkatapos niyan, solve natin yung shear at the left of B. Ba? Na kung saan yung shear at the left of B will be taken as the shear at the right of A plus the area of the load diagram between A and B. And because the load diagram is directed downward, magiging negative ito. Ba? Kaya yung ating value ng shear at the left of B, when we substitute the load, so we have K4W minus 0.25 of P. Ito yung K-value nito. Pag ibawas natin yung W, it will become negative of 4W minus 0.25 of P. Now, if we will factor out the negative sign, so we shall have the left of B equal to negative of the quantity 4W plus 0.25 of P. Yung part na yon, yung point na yun, narito yun. Di ba? At ang kanyang height mula dito is 4W. And then this will be connected now with a straight line because ito ay horizontal. Ibig sabihin, horizontal siya, ang kanyang degree ay 0. So, yung magiging degree ng ating shear will be equal to 1 and 1 will represent a straight line. Di ba? So, pagkatapos niyan, we can now solve for the shear at the right of B. Yung shear at the right of B will be the shear at the left plus yung load at point B. Ang shear at the left natin is this value. Pag idaragdag natin itong load ng bineto, so what we will have? So we have negative 4W plus 0.25 of P, A plus, A the load at the concentrated or the reaction at B, which is 4W plus 1.25 of P. Ito yun, di ba? Kaya lalabas, yung shear at the right of B will be equal to P. P siya, kaya ito yung P natin, di ba? So the value is P. So again, itong vertical gap nito is representing the reaction, the support having a magnitude of 4W plus 1.25. Ito yung part na yan, vertical na yon, di ba? Kaya kung tutuloy natin yon, ang kasunod nating point will be yung right ng C. And the shear at the right ng C dito, okay, will be the shear at the right of B plus the area of the load between B and C. So we have here, yung area ng load natin dito, wala naman sa load, kaya mananatili lamang siyang 0. Kaya pag sinubstitute natin yan, it will be P plus 0 shall remain at P. Kaya it will remain at P here, diba? And it will be horizontal, yung part na yon. And then finally, we can solve for the shear at the right, yung pinakandulo dito. And this will be the shear at the left plus the load at C, and the load at C is concentrated na P. Kaya pag sinubstitute natin yun, shear at the right of P will be P, right of C, okay, will be P minus P, and that is equal to 0. Kaya itong part na ito will be 0, and this downward force will show how the shear will be connected. So ito ngayon yung ating naging shear diagram, at mapapansin natin, yung shear diagram ay nag-cross dito sa ating x-axis at this point. So ito yung ating position na kung saan mapapasok dito yung tinatawag nating maximum bending moment. At tawagin natin itong point D. Ano? Ba? At yung position itong point D mula sa A ay pwede nating makompute sa pamagitan ng naunang discussion na rin natin. Ano? I-divide lamang natin itong shear dito by the magnitude of W. Kaya itong distance na ito ay equal sa 4W minus 0.25 of P over W. Itong part na ito, divide ko lang yung W. Di ba? Sa makatuwid, itong distance nito mula sa D hanggang doon can also be computed. Yan. Diba? Can also be computed, and that is equal to itong part naman ito, itong magnitude mula dito hanggang dyan, that is equal to 4W plus 0.25 divided by W. Diba? Ngayon, bakit ko kinumpute yan? Kasi gagamitin naman natin ito sa pag-compute ng ating maximum bending moment. Diba? Kaya pag kinumpute natin yung maximum bending moment, we solve for the moment at D. Unahin natin itong moment dito sa D. Diba? And how do we solve for the moment at D? Itong moment at D will be our maximum positive bending moment. And this will be computed by starting, let us try to imagine that here is our moment diagram. Okay, narito yung ating point A, ito yung point B, at ito yung point C. So yung moment at A natin will start at, okay, cut. And action. And this point D here, okay, will be the location of the maximum bending moment. At ang ating target, makompute natin itong moment dito, sa point din ito. And wala pala. Cut. At ang target natin is makompute natin, yan. At ang target natin ay makompute natin yung moment dito sa point din ito. So how do we compute for that? We start with the left, ba? So the moment at A natin will be equal to 0. Ito yon. So how do we solve for the moment at D? Yung moment at D natin will be equal sa moment at A plus yung area of the shear between A and D. Itong moment dito plus itong area nito. Itong nakikita nating area dito. Okay? And to solve for the area of this one, so we have a triangle having this base and that as the height. Sa makatwid, yung ating moment at D will be 0 plus 1/2 of the base multiplied by the height. And since base is equal to 4W minus 0.25P over W. So mapapansin natin yung numerator nito ay pareho dito. Kaya this can be simplified to be 1 over 2W times the quantity 4W minus 0.25 of P quantity square. So ito ngayon yung ating moment at D and this is maximum. Diba? So ipakita muna natin, nasan ba itong moment dito? Itong moment na ito ay narito yun, somewhere here, yun. And has a value equal to 1 over 2W multiplied by 4W minus 0.25 of P quantity square. So, then afterwards, target natin ngayon ay makuha yung ating maximum bending moment, negative bending moment at B. So, we can compute for that by applying the definition that the moment at B will be equal to the moment at D plus the area of the shear diagram between D and B. At alin dito yung tinutukoy natin shear diagram? Itong triangular shear na ito. Having a base equal to 4W plus 0.25 of W and a height equal to 4W plus 0.25 of W. Kaya pag i-apply natin ito dito, so we have here ating moment at D. Itong part na ito is the moment at D. Ito yun. Diba? Then, i-minus natin kasi negative siya nasa baba ng x-axis. So we have here 1/2 of 4W plus 0.25 of P over W times the quantity 4W plus 0.25 of P. Ba? And this can be simplified into 1/2 1 over 2W of the quantity 4W minus 0.25 of P square minus 1 over 2W of 4W plus 0.25 P square. Ba? At dahil common yung 1 over 2W, so we can factor them out. So this becomes 1, then expand na natin itong part na ito, di ba? So that becomes 4W square minus the product of 2 times 4 times 0.25 is actually 2WP. Then you have plus 0.25 square, ito yun. So minus the quantity of 1 over 2W times the quantity 4W square plus 2WP plus 0.25 P square. So again, factor ko dito yung 1 over 2W. Kaya lalabas dito, I have here 4W square minus 2WP plus 0.25 of P square minus 4W square minus 2WP minus 0.25 P square. At papasin natin dito sa ating equation, itong 4W ay magkakancel. Itong 0.25P magkakancel din. Diba? At ang matitira dito, negative 2WP minus 2WP will be what? Minus 4WP. And again, yung W will cancel, 2 will cancel, at ang matitira natin, moment at B will be negative 2P. Kaya yung negative 2P natin is somewhere here. Ito yun. Diba? Negative 2P. And then after we have already pointed, shown the points, we can now connect the 3 points by a curve. And Okay, how do we connect it? Paano natin siya i-connect? Gaya ng nauna natin discussion, pwede natin makita siya by looking at the diagram. So, yung load natin is downward, sa makatwid, this segment, segment from A to B will have a moment that is directed concave in the downward direction. Kaya, pag kinonect natin ito ng curve, the curve will run in that direction. Yun, di ba? And then finally, okay, we can compute for the moment at C, which will be negative of 2p. Idagdag lang natin itong area nito. Ilalabas ito ay 0. Diba? So, it will be connected with a straight line kasi ito yung horizontal. It will be straight line in that direction. O, diba? Ngayon, may gusto ko sanang ipaunawa sa inyo. Kanina, pinakita natin that we have solved, okay, we have solved the value of the moment A at B, which is negative 2p using the relationship between the moment at D and the moment at B, diba? Which is taken by the relation that the moment at D, B will be equal to the moment at D plus the area of the shear from D to B. At in our computation, naging medyo mahaba-haba, ano? Kung medyo sabi nga, kung medyo tinatamad-tamad ka, baka isipin mo, mali na yung ginagawa mo, ano? Kasi ang haba-haba na yan, at hindi mo naman siya basta-basta magagamitan ng calculator kasi yung ating moment is expressed in terms of two variables. We have W and P. Diba? Kaya talagang pagtsatsaga mo na simplify siya using your long hand. Ano? Kaya kinakailangan magtsaga na masimplify siya. So medyo mahaba. Kaya delikado na magkamali. Ngayon, meron akong gusto ipaunawa na itong ating moment at B ay pwede namang masolve natin siya using other solution. Diba? Yung mas mabilis na solution. And how are we going to do it? So we will be using the definition of the moment. Na kung saan yung definition of moment will be equal to the summation of the moment taken on the left or on the right part of that exploratory section. Kaya kung kinukuha natin yung moment at B, so kinakailangan lamang na magpas tayo ng exploratory section dito. Diba? At yung moment dito will be the summation of moment kapag ang kinuha natin yung left part o kaya yung right part of the exploratory section. At mapapasin natin, diba? If we will consider the right part of the exploratory section, okay, so you will have a very, very simple moment. And the moment will only be equal to the moment due to P multiplied by the moment arm of 2. Kaya yung ating moment will be P multiplied by 2 and y negative kasi ang definition natin ng moment will be positive kapag ang beam will be concave upward at negative naman kapag yung beam will be concave downward. So mapapansin natin dito, itong pineto kapag in-apply natin dito sa beam will cause the segment BC to concave in the downward direction. Kaya inaasahan natin na yung moment that will be produced by this P upon B will be causing a negative moment and that is equal to a negative of 2p. Kaya itong value na ito is also the same as this one, di ba? So ngayon, saan ka ngayon na alin ngayon ang gagamitin mo? Will you be using this part or using this part? Kung hindi mo alam na i-apply yung definition, baka nga mahulog ka na ito yung gamitin mo na medyo delikadong approach kasi dahil medyo mahaba, baka magkamali ka at marito ka on the simplification. Kaya pinakita ko yung definition ng moment kasi kaya kinakailangan maintindihan natin na meron pang other solution or approach in solving for the moment at P which can be taken using this definition. Diba? Now, pagkatapos natin makuha ngayon yung maximum positive bending moment at maximum negative bending moment, siguro mas mainam na i-summarize natin yung ating initial results para makita natin kung paano natin susundan yung ating computation. So una, balikan natin yung ating moment capacity na kinumpute natin is already computed at 20.25 kilonewton meter. At meron tayong maximum positive bending moment taken from this diagram. Ito yung part nito, and that is equal to 1 over 2W times the quantity 4W minus 0.25 of P square. Ito yun, di ba? At meron din tayong maximum negative bending moment which is equal to K2P and that's actually negative. Yung absolute value niya is 2P. Ito yon. Now, Gaya nga ng pinaliwanag ko kanina, kinakailangang ma-equate natin itong kanyang maximum moment capacity to both of the maximum positive and negative bending moment. At kung mapapansin natin, yung ating maximum negative bending moment is expressed in terms of one of the unknown, that is P. Kaya kapag itong dalawa in-equate natin, automatic, okay, masusolve na agad natin ang value ng P. So if we're going to equate the moment capacity of the beam with the maximum negative bending moment, from there, masolve natin itong value ng P. And so our equation will be 2P, representing what? The maximum negative bending moment is equal to 20.25, representing the moment capacity of the beam cross-section. Kaya from here, masolve natin yung value ng P of 10.125 kilonewton. Now, pagkatapos nating masolve itong 10.125 kilonewton at isinubstitute natin siya dito sa moment equation kay maximum positive bending moment, di ba? Then, inequate natin siya sa kanyang moment capacity, masosolve na natin ngayon yung kanyang W. Kaya, when we simplify, 1 over 2W times the quantity 4W minus 0.25 P square, itong part na ito is the maximum positive bending moment. Samantalang ito naman, yung moment capacity ng section. Ito yung maximum positive. Now, substitute natin ngayon yung value ng P, di ba? Simplify natin, substituted the value of P, then we will be having an equation 16W minus 2W times the quantity 10.125 plus the quantity 0.25 times 10.125 square will be equal to 40.5 W. At pag sinimplify natin ito, magkakaroon tayo ng quadratic equation kay in W. And this is equal to 16W square minus 60.75W plus 6.407 equal to 0. Now, if you have now your calculator, okay, or using your quadratic formula, you can solve for W, and W equal to 3.69. So, ang ibig sabihin nito, okay, the maximum P that can be applied simultaneously with W will be equal to 10.125 and 3.69 kilonewton per meter respectively. At yan ang solution sa ating problem, sample problem. No? Sana guys, sa pamamagitan ng sample problem na nakita natin ngayon ay mas lalo ninyong naintindihan kung paano i-solve ang problem, okay, particularly on the stresses ng beam. Ano? Kaya naman patuloy nyo akong subaybayan sa pamamagitan ng pag-subscribe dito sa ating channel, at kung may mga kaibigan ka na sa palagay may kailangan ang ganitong klase ng discussion, share it to them para naman sila ay na-update din ng ating discussions. Once again, thank you very much for watching.